This section is about text summarization, and we are going to look at the agenda of this course. We will discuss about what is text summarization, and there will be two kind of tests: abstractive and extractive. So we will take a look what is the meaning by abstractive and what does it mean by extractive. And we are going to learn some metrics regarding to the text summarization. So there are three important metrics. The first is blue, BLEU. The other is rock and metal. We will take a look on the details. And we are going to look at the algorithms, how we can do the text summarization. There are some algorithms like frequency-based abstractive summarization. We can use TF-IDF and we can use the text rank algorithm. And at the end, I'll give you the summary. So the text summarization, you can look at these figures. We have a lot of books, okay? We have a lot of documents, and we want to make summary. Summary is like yoyak or the abstract. Text summarization, we call it the text summarization. So the task is to produce a short or a bridge. You know, what does it mean? Bridge is something that is the summary, or we call it short version. So this is a short version of a text while retaining the key. The key means we want to know what is the key point of the documents, and we want to check what is the relevant information. So this kind of text summarization, it is useful for creating the outlines. The outlines in that if you have document, you put only the important point. Usually we put with the dot. So let's say I want to know what are the importance of the document. So there will be 5 things that we can see from the document. Then we can put this into the first outline, second outline, third outline, and so on. Or we can do the abstract. Abstract is yoyak. We can also make the summary of chat and email. In the chatting, if there are so many words, we can make a summary. And also when you do email, if the email is too long, maybe you are difficult to understand the long email, then you can ask to create the summary. Meeting. If you have meeting and the meeting runs for 1 hour and there are so many discussion on the meeting, then you can create some action items. Or if you have the sentences, if there are too many sentences like this one, so you can simplify the text. So simplifying the text means we want to compress the sentences. So the text summarization, we can have a kind of input and output. So if the input is a single document, we call it this is a single document summarization, SDS. If there are many documents, then we call it this is a multiple document summarization. The approach can be supervised. The supervised means you have the reference. So I know that the documents is related to AI. Then we can make the summary. This document have the word artificial intelligence, or this document have the word machine learning, and so on. So if the word contains the AI machine learning, then this document is related to the AI, and we can have like the performance metrics. If the precision is high, then okay, this document is really related to AI and machine learning. Or the other kind of approach, we can use the unsupervised learning. If it is unsupervised, it means I do not know what is the context, what is the key point of the document. Then you can do some kind of clustering. You can check based on the TF-IDF. So what is the most important word in the sentence, and etc. So after we know the approach, whether it is supervised or unsupervised, then we need to check the output. So the output can be single document. Single document means only one document. Or there can be multiple documents. So you have many documents, not only a single document. And the focus of the stack summarization, you can check whether the focus is generic. Generic means whenever you have a document, you just extract from this document regardless the context. There is no condition or unconditioned. If the other kind of focus is query focus, query. What does it mean by query? It means we have a specific keywords. We have a specific request. For example, I want to make the summary about the documents related to economy. Then I need to check the word related to the economy. For example, money, investment, or something words related to the economy. So you have the query. This is the query. The query means I have a condition that if the document contain about money, if the document contain investment, okay, then we have a kind of supervised approach. We have a precision to measure, okay, the summarization, if it is related to money, then the precision might be high. In the single document summarization, we have a single document, so given a single document, and let's produce the abstract. So this is the Joyak. And outline. So we have several points, and we can also produce headline. In the news, you can see the title, and sometimes they have headline in order to understand the contents for the readers. So this headline is a kind of summary. Maybe usually it is only like 3 until 4 sentences. Multiple document summarization. So we can have more than one document, even a group of documents. It produces a series of news story on the same event. Set of web pages about some topic or question. So for example, if we are now just finishing about the APEC. So there are many news related to the APEC 2025. So you get the news from maybe CNN. You got the news from BBC. You got the news from Bloomberg. And you also got the news from Korea Times. or you can get the news from Dungan Ibu, and so on. You collect all those documents and you want to create a summary, whether all the news give the same result or not. It is the same with this one set of web pages. There are several web pages and you want to know whether they give the same topic or they have the same question or not. In the single document summarization, you can see like this example. We have a document. Maybe if you read English, you may have some difficulties to read all those details. Maybe you are busy with other things. You cannot read all. Once you do the summarization, yeah, we can have only the summary and read that, okay, this is related to the Cambodian government rejects the opposition call for talks abroad. Okay, we don't need to read all those details, but we know that this document is related to this topic. In the multi-document summarization, so there are many documents. Maybe, for example, document 1, document 2, document 3. Okay. So the example in this case is about the flight MH370. Do you know about this? This is a big incident. This is the Malaysian airline which fell down, and no people understand why the airplane fell down, and until now they cannot find the airplane. So there are many news. This is the news from one side. This is another news. This is another news. Okay. So this is from the Malaysian government. So this is from CNN. This is from Vietnam. And we want to make the summary. What is the summary from different kind of perspective? So this is the summary. In order to show the summarization, there are two kinds of summarization. The first summarization, we call it extractive. Extractive summarization, it means we select from the source text spans that capture the key information. It means I have the sources. Let's say the sources, maybe the first is CNN. The second, let's say, is from Bloomberg. Next, maybe it was from BBC. Okay. After you collect those, you see that the most easy understanding news is CNN. Then you will select these sources and then you do the summarization based on the CNN. So we only extract from one source. But the abstractive summarization, we call it, this is abstract. It will generate a new text that encapsulates the key information from the source text. It means if we have the source like CNN, we have the source like from Bloomberg, and we have the source from BBC, we will generate a new text. So we will generate a new sentence. We will generate a new things as the summary. So this figure can show you if we have the text, the sentence 1, sentence 2, sentence 3, sentence 4, sentence 5, sentence 6. With the extractive summarizer, we will select what is the best sentence. In this case, maybe we select sentence 2 and sentence 4. For the abstractive, we have sentence 1, sentence 2, sentence 3, sentence 4, sentence 5, sentence 6. And using the abstractive summarizer, we will create a new sentence. So the new sentence is something new. There is no reference from this sentence. In the generic summarization, we want to summarize the content of the document. Means regardless any query, regardless the condition, so we want to get the summary. But the query focus, it means we want to summarize a document with regard to the user's query. So the query refers to some kind of keywords or the request from the user. Complex question and answering. So answer a question by summarizing a document that has the information to construct the answer. So it's like chatbot. When you do the chatbot, it means you need to know the topic. If the topic is about smartphone, then this chatbot should have the sources about smartphone. Maybe the documents related to the manual of the smartphone, maybe the documents related to the devices of the smartphone, maybe the documents related to the warranty of the smartphone, and etc. So the chatbot should collect any documents related to smartphone to get the correct answer for chatbot. And after we do the summarization, we can put those things into the chatbot. Whenever there is a question, the chatbot can answer automatically. So the query focus summarization, it is a kind of snippet. So the snippets, you can look at Google. Okay? Whenever you write something, for example, how long did World War II last? So this is a query. This is a question that you put on a Google, and then Google will give you some portion of the summary. So if you look at the result here, there are about 5 billion results. But the most important part will be in the top, and the next will be on the second, and so on. So this is one of the example for the query focus summarization. In the query focus summarization, we want to create the answers from the complex question. What does it mean by complex question? The question is too abstract. The question is too general. It is too general. So you can get that from multiple documents. So you can get from many documents. You can get from many web pages. Instead of giving a snippet for each document, so you can create a cohesive answers. Cohesive answer means the answers that are most related to the query. It means if we have the topic or the query about World War II, then the most cohesive answers, it will be related to history. Then you need to check any website that provide history. So we need to create a cohesive answer that combines the information from multiple documents. Maybe the example that I show you before. The result is from the history.com, and the result is from the Wikipedia. It means all the information which is publicly available, they are trying to extract into the answers for the query what to. Okay, for this one, does this seem like a job for extractive or abstractive summarization? So if we do like this one, create the answers to complex question. Is it extractive or abstractive? It is difficult to answer because when you have the complex question, sometimes we need to get a good answers. So the good answers might be in one source. The good answer might be in the one web page. Then we can extract directly from one web. But if it is too complex and it is not available in any document, if it is not available in any web, then you need to make the abstractive summarization. In Google, so Google always try to find the extractive. That's why whenever you search on Google, when you do some kind of query like this one, they will give you the result which is almost similar to your query. So they try to find the most similar keywords with the query, and then they will show it. So we call this is the extractive. Google always try to find the extractive, but some other case you may have the. Now we can see the text summarization. It requires a kind of matrix. It means when you do the summarization, we want to know whether the summary is good or bad. We need to have a metric. For this metric, there are several quantitative metrics to assess the outcomes of this model. Some traditional metrics, for example, BLE, blue. The other kind of metrics is rough, and the other of metrics is Meteor. So let's look at the detail. Let me start with rough. Rough, ROUGE. So it stands for recall oriented understudy for testing evaluation. In the rough, it measures the precision and recall. Okay. So those are the two metrics of the generated summary with respect to the reference summary. So we have the precision, we have the recall from the reference and the summary. And in rough, usually we use the n-gram. You still remember n-gram? If n equals to 1, then it is unigram. If n equals to 2, it means bigram. And this n-gram, sometimes we call it the co-occurrence statistics. In the rough, specifically, it computes the precision and recall for the overlapping n-grams of different lengths, ranging from unigram, single words, to the longer subsequence of words. So the longer subsequence of words, it can be n equals to 2, maybe 3, maybe 4, maybe 5. Yeah, it depends on the length of the sentences. The higher rough score, which is from 0 until 1, it means if it is nearby 1, it indicates better alignment with the reference text. If it is 1, it means that it is a perfect match. Or we can say 1 equals to 100%. So the metric show it is a good performance. The rough can be distinguished into some variant. For example, we have the rough n. Rough n, it is to indicate the n-gram. So we have the overlap of the n-grams. N can be any number, any integer number, but mostly people just use rough one. It is to measure the overlap of unigram, single words, or they use the rough two. It is to measure overlaps of bigram, which is two words. If the rough one or the n equals to 1, then it is unigram. If the rough 2, when n equals to 2, then it is bigram. There is also another variant, we call it rough L. L means the longest common subsequences, or we call it, this is LCS. The LCS, or the longest common subsequences between the generated text and the reference text, focusing on the sentence level fluency. So if the sentence is too long, of course, we need to find what is the longest common subsequent. There is another kind of measures, we call it rough W. W means weighted. Weight. In Korean is 다중수. We have a weight for the rough L, giving more importance to longer consecutive matches. If the word is long and the longer reference text, the same with the longer summary text, then we give higher weights. The other kind of variants of rough, we call it rough S. Rough S measures the overlap of skip bigrams. The skip bigrams, it is similar to the skip gram, if you still remember. If in the skip gram you have words, and then you skip one word, and then you want to predict what you already skipped in this case. In the skip bigram, it means we have bigram, two words, then you want to look at the missing, it allowing some gaps between words in the matching process. So we have the skip bigram instead of the skip gram, and we can use the rough S to measure the metrics for the text summarization. Now let's see how we can measure the rough one. As I mentioned to you, rough one. One means unigram. In the unigram, we have only one word. So the reference summary, the cat sat on the mat, and one word, the cat sat on the mat. So this is the reference. For the result on the summarization, we get the result. The cat is on the mat. This is the reference. This is the generated. The generated shows like this one. The cat is on the mat. You can see this word match. This word match. What about this word? It does not match on the order. This one match. This one match, and this one match. Okay. So for the unigram, Yeah, we can split the token like the cat set on the mat like this one. The cat is on the mat. So the overlapping unigram, there are five. One, two, three, four, five. Now we know that the overlapping unigram is five. In order to calculate the precision is the number of overlapping unigram, which is five, divided by the total unigram in the generated summary. So in the generated summary, we have 1, 2, 3, 4, 5, 6. Okay. So among 6 words, 5 words are the same with reference. Then we call the precision is 0.83 or 83%. What about recall? For the recall, we also look at the number of overlapping unigrams. The number of overlapping unigrams, there are 5. And we are going to divide with the total unigrams in the reference summary. So we are using the reference. The reference in this case, we have 1, 2, 3, 4, 5, 6. Okay, it is the same, 6 words. Then the recall will have the value 5 over 6. From the total 6 words in the reference summary, we have 5 words are. Then the recall is 0.83. In many cases, we cannot use only precision and recall. We also need to use the F1 score. If you learn in the data science, I think you will learn this metric. The F1 score, we have the formula 2 multiplied by precision multiplied by recall divided by the precision plus recall. So you can just put the value 0.83 for the precision, 0.83, which is the recall. And then we have the precision plus recall, 0.83 plus 0.83. The F1 score result is 0.83. Then we can say that the rough one, or we call it, this is F1 score, the rough one is 0.83. So this is for rough. Now let's suppose we have another matrix which is rough 2. So 2 means bigram. In the bigrams, it means we want to check 2 words. Let's say this is the reference summary and this is the generated summary. The cat sat on the mat. The cat is on the mat. Then we want to get every 2 words. The bigram will be the cat sat on the mat. For the generated text or the generated summary, we have the cat is on the mat. Then we can make something like this one for the display. The cat and the cat. Cat set. Cat is set on the mat. The mat. The overlapping, there are 3. Okay. 1, 2, 3. The count of overlapping not unigram, bigram. Okay, so this is not unigram, this is bigram. So there are 3, and we again calculate the precision and recall. The precision is the number of overlapping bigrams. The number of overlappings, there are 3. and the total bigrams in the generated summary. In generated summary, we have 1, 2, 3, 4, 5. Then the precision is 3/5, 60%. The recall is using the number of overlapping of bigrams, which is 3, divided by the total bigrams in the reference summary. The total bigrams in the reference summary, we have 1, 2, 3, 4, 5. Same with the precision, we have 3 divided by 5, then it is 60%. Then we can calculate the F1 score. Again, we will get the F1 score with this formula: 2 multiplied by precision multiplied by recall divided by precision plus recall. Then this is the F1 score. At the end, the conclusion is rough 2. With the rough 2 matrix, the F1 score, the rough 2 score is 0.6. Using this value, we can compare rough 1 compared to the rough 2. So the rough 1 is higher than rough 2. Rough 1 shows 0.83 and rough 2 shows 0.6. There is another matrix, we call it BLEU, BLEU. It is a bilingual evaluation under study. This metric primarily used in machine translation. Machine translation, 번역기. But it is also applicable to any task that compares the generated text to a reference. Okay, same. We have the reference and we have the generated summary. So we want to check whether the reference is the same with the generated summary or not. You can use the BLEU. It evaluates how well the n-grams, again, it is the phrase of the n words in the generated text match those in the reference text. And we are going to use the precision-based approach. The BLEU scores, it is from 0 until 1, or from 0% until 100%, where the higher scores indicate closer match to the reference. If it is 1, then it is closer to the reference. In the BLEU, there are some variants. We can use the n-gram precision. N-gram precision means it depends on the n. If n equals to 1, then it is the unigram precision. If n equals to 2, then it is bigrams precision. You know how to calculate the precision, and this precision will be for the BLEU. So the BLEU calculates the precision of different n-grams by measuring the proportion of n-grams in the generated text that match the reference. So we use the precision. There are another kind of variance, we call it the brevity penalty. So the brevity penalty means it includes a penalty. So there is a kind of penalty to avoid favoring shorter generated text over longer ones that closely match to the reference. This penalty is applied if the generated text is shorter than the reference. If we have 1, 2, 3, 4, 5, 6, 7, 8 for the reference, and then the generated text, we have only 1, 2, 3. So if it is shorter, the penalty is applied if the generated text is shorter than the reference. Because it is shorter, then we put a kind of penalty, because this is not the same length of the reference. We can use the geometric mean. The geometric mean, it refers to the geometric mean of the n-gram precisions. So the PLEU calculate the geometric mean of n-gram precision from n equals to 1, which is unigram, n equals to 2, which is bigram, n equals to 3, which is trigrams, and usually up to 4 grams. So until n equals 4. And we will calculate the geometric mean. 1 plus 2 plus 3 plus 4, and we will divide with 4. So the precision when the unigram plus the precision of unigram, bigram, plus the precision of trigrams, plus the precision of 4 grams. And then we will plus everything divided by 4. Then we will get the value of the geometric mean for PLE. Now, let's see with this example. Let me just use the PLEU2. Okay. Oh, sorry, this is the unigram. This is the bigram. Okay. This is unigram. This is bigram. Let's see different example. I think in the internet there are many similar examples like this one. The quick brown fox jumps over the lazy dog. The generated text or the summary is a quick brown fox jumps over the dog. Now you can make the token. The token means, yeah, the quick brown fox jumps over the lazy dog. You can see the unigram. There are 7 matches. Okay, 1, 2, 3, 4, 5, 6, 7. There are 7 matches. For the bigram, you have the word the quick brown fox jumps over the lazy dog. And the other is a quick brown fox jumps over the dog. So we have 1, 2, 3, 4, 5, which is matching. So we can calculate the unigram precision, which is the number of matching divided by the total generated text. So the total generated text, you can see 1, 2, 3, 4, 5, 6, 7, 8. So there are 8. And the unigram precision is this one. We can calculate the bigram precision. The bigram precision, the number of matching is 5, and the total of bigram of the generated text, there are 7. So the bigram precision is 0.71. We can calculate with the geometric mean precision, which is from the PLEU score. We use the square root of unigram precision multiplied by the bigram precision. We have the unigram precision multiplied by the bigram precision, and the score of the geometric mean of precision of 0.79. And yeah, we have the final score, which is the exponent of 1 minus reference length divided by the generated length. For the reference length, we have 9 words, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the generated length, we have 8. And then we do with the exponent, we got approximately this one, 0.89. So the BLEU score, the total BLEU, it refers to the BLEU score, which is from this one, multiplied by the PP, which is regarding the gravity penalty. So this is the penalty. The penalty because this one is shorter than this one. Then the total is 0.7. So we can say the generated text captures about 70% of the key phrases in the reference text, considering both unigram and bigram overlaps. So this is the unigram, bigram, and you can look at the generated text and the reference text. Okay, I think due to the time, let me just stop here. I will continue with the meteor tomorrow. Okay. Any questions?